Hello YouTube. The past 3 weeks have been super busy as there is another scheduled launch coming up very soon. As a result, the e-journal entries have been delayed until now. There's a lot of material that needs to be covered today, so let's get started. If you've seen the test launch video for this rocket, then the reason is fairly clear why the past 3 weeks have been so busy. The initial liftoff was not horrible, but it wasn't straight, and it failed to hit the 800-foot mark with its apogee marked at 646 feet. This became the least of my worries when, after a 6-second delay, the charge used to blow off the payload section was so powerful that it ripped the bulkhead out of the lower payload bay's coupler. This resulted in the bottom of the rocket coming down with a parachute, and the other to tumble chaotically to Earth. The egg ended up breaking through the Ziploc bag and foam holder, making a mess, and one of the fins wasn't glued on as well as the others and got dislocated. Test flights, especially the first one, are never perfect, but this particular flight exceeded my worst expectations. With the bugs from the launch identified, I immediately set to work on resolving these issues. The first issue I was able to mend with just the tools at my house was the faulty fin that dislocated itself during the launch. I cut the paint away from the through-the-wall tab and found that I sanded it a little too short on one side, reducing the amount of surface area connecting the inner motor mount tube. I managed to increase the amount of surface area contacting the inner tube by measuring out a small piece of basswood, gluing it to the shortened fin tab, and sanding the modified fin until a level uniform shape was created. I reattached the mended fin to the rocket, however it would have to be removed again after trying to open up the bottom of the rocket to reduce the ballast in the lower half. The 125 grams of superglued metal ended up making the rocket too heavy in real life, and its slightly uneven distribution may have contributed to the slight diagonal flight when tested. I tried for at least 30 minutes to safely remove the motor mount with a Dremel. However, the combination of superglue and wood glue held fast and forced me to do something I never thought I would have to do: redesign the rocket. I dropped the Dremel job and went onto RockSim, removing all the rear ballast and shortening the main body tube by 5 inches. The simulation flew straighter than before, and the reduced weight allowed it to go considerably higher in the digital world. With that, I turned on the bandsaw and amputated the entire motor mount setup, leaving my once finished rocket back to a bunch of painted tubes. Before destroying the old motor mount, I salvaged the 3 fins and 1 centering ring that would be used to construct a new mounting system. It was not fun seeing the rocket that took so many hours to finish being reduced to parts due to an inability to reach the rear of the rocket. So I further complicated the new design by creating a removable motor mounting system that could be serviced at the launch site for just about any repair or modification from fins to ballast. The design settled upon was similar to a typical motor mounting system, with centering rings, fins, and motor retainers. However, it would need 2 wooden centering rings glued at the bottom as opposed to 1, so that I could hold screws to keep the motor fast. And the fins would be completely separate from the main body tube, reducing some of the rocket's aerodynamics. Simply said, it was a very risky approach to an already crippled rocket. All the new fin slots on the body tube had to be hand-cut, which were nowhere near as clean as the pre-cut tubes. Gluing the fins were even more tedious, as the only support in keeping them up while they dried was some painter's tape and a lining cut out. The assembly was frustrating, however, I was able to put all the elements together with as much precision as I could, and there were no regrets with the results. In the end, I was able to revive this rocket and even make it better than before. It is a more manageable piece of engineering, with a removable motor mount to ensure that servicing reaches all aspects of the rocket's performance. Due to the test flight 3 weeks ago, I managed to create something that I truly haven't seen in a rocket of this size and purpose. The care and intent put into this flying machine only adds to the incredible story that has been created. And well, I just hope that this will be the last time I have to rebuild this thing. I hope you enjoyed this video. I'm super sorry that I've been so behind on the e-journal entries. I'll be getting back into hopefully a weekly schedule of uploading. If you haven't visited the American Rocketry Challenge's website, I strongly encourage you to check it out in the description below. Don't forget to like, comment, and subscribe to keep up with all of my STEM projects, and I will see you next time.